All right. So basically, before we get into cybersec, as I mentioned the other time, we have to get some basics, and all the things that we have here will still are still stuff we'll be working with when we get into information security, cybersecurity. So what we'll be looking at today is understanding basic networking concepts. So I'm going to run through the course outline. I'll just have a high level overview of what you should be able to do at the end of this training. So understanding basic networking concepts. This is going to bring us up to speed with networking terminologies and the whole essence of having a computer network in an enterprise environment. What are the benefits of having a computer network? We'll look at network cabling. Cables are those things that allow us to connect our systems to the network. And we look at the major concept of this training, the TCP/IP, and then the OSI model. This will help us to know what is an IP address, how do we assign it to a system, what are the different classes of IPs, and then we'll look at the open system interconnection model, the OSI. There we are going to understand what works and what does not work in an IT network. We'll look at the different layers on the OSI, will help us to understand if we have issues with a particular system, with a particular network. It could be connectivity issues. We'll be able to know where the issue is happening and what we need to do to fix it. And that's the essence of OSI. We'll look at TCP/IP subnetting, and that is working with binaries. And the first practical in this training will be setting up and configuring a local area network, that is building up a wired network and have all the systems on the network interconnect and share resources together. We'll look at how to configure file sharing, how to configure printer sharing, so that any of the staff we have on the network can locate the printer and print whatever document they want to print. And we'll look at wireless networking. So in your home, you could have a little device provided by an ISP, the internet service provider. All the devices you have at home connects to that device in order to have access to the internet. So how do we get those devices set up? How do you secure your wireless so that your neighbor will not be able to break into your home Wi-Fi? Those will be covered in wireless networking and wireless network setup and configuration. As a matter of fact, here, where I actually trying to highlight here, we'll be looking at how to set up a wireless network. So this very place here. And then we'll look at LAN switching technologies. A host of things will be done here. If you're looking at building an enterprise network, like the ones you see in banks or any corporate environment, you need to understand what LAN switching is all about. And we need to know what is a switch and see how to set up a switch in an enterprise environment. IP routing technologies. Here we are going to talk about interconnectivities. You might work for a firm that has maybe their main office is in Canada, and they could have a host of branch offices within and outside of Canada. And you might be saddled with the responsibility of connecting these branch locations to the corporate head office in order to share resources that you could have provisioned in the head office. And so IP routing will learn the skills of connecting multiple branch office locations to the corporate head office. And we also see how we can configure things like VPN, remote access VPN, so that some of our staff could work from home. And that's what IP routing technologies is all about. We'll look at some security aspects. Access control list. We can use an ACL or access control list to limit or control what resources the staffs that are connected on the network are allowed to access and what resources they are not allowed to access. So it's about limiting people and permitting people to do stuff on the network. That is ACL, access control list. And without NAT, also known as network address translation, nobody on the network will be able to browse the internet. So we'll see how to set up NAT so that all the devices we have within the network can access the internet. And then we'll look at cloud. So one of the things buzzing in the IT field today is cybersecurity and secondly cloud computing. These are leading fields in the IT landscape. So we'll look at cloud foundations. As a cybersecurity professional, you need to understand the cloud technologies, because if you work for a firm that have some of their resources in the cloud, it's still your responsibility to know how to protect these cloud-based resources. So we'll look at different cloud service providers like Microsoft Azure, Amazon Web Services, aka AWS, and also look at Google Cloud Platform. These are the three major leaders in the field of cloud. And the VPN, I mentioned it earlier on the IP routing. So there is a segment that will focus specifically on VPN technologies. And look at some aspects of network automation, because sometimes you might not be setting up IT equipment, security equipment manually. You might want to build a script that will help you to auto-configure all these devices, especially when you have hundreds of devices to set up. So there is a need to use some automation tools like Chef, Puppet, or Ansible to get these tasks automated and save us some time that we can use to attend to other issues. So this is a high level overview of what we should be able to know how to do at the end of this training. However, this is going to start from the very beginner level. So regardless of the field that we are coming in from, we should be able to cope. That's why we are starting from the very beginning. So with no further ado, we can now get into the first topic. I would like us to cover just this one today so that we take it gradually as we progress in the training. We might cover 2 or even 3 topics per class. But for today, let's just take this one and then we start on network cabling, another class. So let's look at understanding basic networking concepts. First off, we need to know what exactly is networking. We need to know the benefits of having a network in the first place. And we also look at different types of network and look at network devices. So those 4 bullet points you see here will be what this first topic will cover, which is understanding basic networking concept. So what is a computer network? Networking basically is a way of interconnecting 2 or more computing devices. So here, it doesn't necessarily need to be a computer. So we use the term computing devices. A computing device could be a smart TV. So you could have a TV in your home that could connect to the internet, and you could be watching stuff like Netflix from your television. And that makes that device a computing device. So it could be from your microwave oven, it could be from your refrigerator, your air conditioner. This is all about IoT, which is Internet of Things, where all the home appliances we use today can now have access to the internet. So any form of interconnecting 2 or more of these computing devices together for one single purpose, which is sharing information and resources, that is what we call networking. So if we set up a network in the first place, this network will be wired, which means that everybody will be connected with cables. This network could also be wireless, which means that nobody will be using cables, so we'll be using passwords to connect to the network. Whichever type of network, wired network, wireless network, the objective is the same. We want to be able to share information. We also want to be able to share resources, but we need to throw more light on what we mean by information sharing and what we mean by resource sharing. Well, I have an example here, but this is not limited to the only things I have here. So when we talk about information sharing, first it could be file or document sharing. So if I want to, maybe I'm looking for a job and I want to apply for a particular cybersecurity job role, maybe cybersecurity analyst or cybersecurity penetration tester. Of course, I need to get my CVs to the employer. They'll be able to review my CV, and my CV could give them an insight on my capabilities, my competence. And so that CV fall under file or document. I don't necessarily need to get down physically to their office location to submit my CV. So because we already have a network, I could leverage that benefit of having a network and use something like mail to send my CV through a network to the employer. And so that falls under file and information or file or document sharing. So with a computer network, we should be able to move documents across the network without having to really be in person to submit those documents. Now, what about video conferencing or video streaming is also part of information sharing. A couple of a few months back, like 2 months back, the World Cup was ongoing. Yeah, so I know your country at a point we were knocked out. That is Canada, right? You followed the World Cup. I want to assume you watch football, and you don't necessarily need to be physically present over there in Qatar. So you could. There are so many websites that bring us these feeds. We connect and watch the football matches live as if we are in the stadium. So video conferencing, video streaming wouldn't have been possible if there is no network. And when you are streaming, it simply means you are getting feeds, you are getting information about what is going on live in that venue without necessarily being there live, right? So that is information being shared once again. Now, if you have an ATM, so ATM cards, so of course you should be able to withdraw some cash if need be from an ATM, which is automated teller machine, using your ATM card. Right? A whole lot of networking happens before a customer is able to withdraw from an ATM. Could you just help me with 2 banks? Let me use it in this analogy.
TD.
You have
TD.
TD.
Yeah.
Okay. And which other bank?
And RBC.
RBC.
Yeah.
RBC.
Yes.
All right. So let's say you bank with TD and you need some cash, and the ATM you could find is not TD ATM. So the ATM you could find is RBC ATM. So it doesn't really matter your card should still be able to work on another bank's ATM. Why? Because there is a high level networking that are already in place. So there is always a gateway, like a switching company that all the banks will connect together. So this bank will have to connect to this switching company, and this bank will also have to connect to this switching company. And these connections here are networking connection. And so for this bank, RBC, you are not banking with them, so they don't have your details. They wouldn't know if you have some cash in the account. Before they approve the withdrawal, they will have to reach out to your bank and say, hey, a customer with the following details is about to withdraw some cash from our machine. Should we let the person go ahead? And your bank is going to get back to them, say, yeah, he has or she has money in the account, approve the transaction. And so these things happen at the speed of light. Within 1 to 30 seconds, the information is shared and you are allowed to withdraw some cash from another bank's ATM. And this actually is part of networking and part of information sharing. So without network, we virtually can do nothing. And then when it comes to the second benefit of having a network, that has to do with resource sharing. First off, we need to know what is a resource. Anything that is useful for an employee to do their official duty is a resource. Anything at all that is useful to any of your staff to do their official duty, that thing could be in the form of a software. It could also be in the form of hardware. That is a resource. And so here, let's look at an example of a resource as a software. An example of a resource as a software would be, at this point, or come here to the whiteboard, it could be an antivirus. And every system on the network needs antivirus installed. It could be Norton, it could be any vendor, it could be Kaspersky, it could be McAfee. But the point is the antivirus solutions help us to protect our systems from malicious software, aka malware, right? So when we get proper into cybersec, we'll look at malware in detail. But malware is a malicious software that, if it gets into your system, could steal some data without your consent. And so we need to install antivirus so that we'll be able to protect our systems from malicious attack. Well, what if we have like 400 employees? So these 400 employees means that you'll be needing to install the antivirus not on 400 computers. Well, how are we going to go about it? Two ways or two options. We could do this manually. Second option, we could automate it. Now, if we do it manually, it means that you, the IT engineer or the cybersecurity professional, will have to have access to the DVD that has the antivirus. You have to go from one system to the other to install this antivirus. And the average time for installation is 30 minutes for you to get done with one system and move on to another system. Meanwhile, you have 400 systems to do that on. So it's impossible that you finish this in a day, right? Because there could be some other issues coming up in the network that needs your attention. So at one point, you may have to leave whatever installation you are making and attend to other issues. So manual installation wouldn't work in a production environment. So what we can now do is automate the process. So if we want to automate the process, it simply means that we need a network, right? So we need a network.
Yeah.
And over the network, we need to configure certain stuff. One of the things we configure on the network is called multicast transmission. So what will multicast transmission help us? It will help us to push this antivirus solution to the 400 PCs on the network at the same time, right? So all we do is program some instructions and let the server know where those systems that we want to install the software are located on the network. And then the server could go ahead and do that within 1 to 15 minutes. And we could have this antivirus software installed in 400 or more systems on the network. And that's actually one of the benefits. It helps us to share resources. Example, a software installation could be automated. But if you don't have a network, maybe you have individual systems and each system has its own individual source of internet connection. That means we don't have a network. In that case, the only way to go about it is manual installation. Okay, so now what about the second example here, which is hardware? Because when we're looking at a resource, which once again is anything that an employee may be needed to do their official duty, who could be in the form of software, but it can also be in the form of hardware. So could you think of anything hardware-wise that an employee may be needing to do the official function, hardware-wise? Could you think of anything hardware?
Like hardware to install the antivirus?
Okay, but antivirus would fall under a software, is a software.
Oh,
Right?
okay, so could you ask me the question again? Yeah.
So the question is, could you think of anything hardware-wise, anything that is hardware that can be useful to an employee to do the official duty?
Hardware.
Hardware.
Software program that they can download.
Okay, so let me help you out. Now, here, when we talk about hardware, can you think like a printer?
Oh yeah, printer.
A printer is one of the examples. Yeah. So yeah. So if we have a printer, sometimes it's not all the times that you use the your documents. Most of the time will be electronic documents, but sometimes you may have to need hard copies. You need to print it out. And
yes, and
how do we?
print and you have to sign it.
Yes.
Usually when they need it, companies signature or like physically, that's what they ask you.
Yeah.
Print the document.
Yeah, we have some some pads that can allow us to sign electronically as well, right?
Correct.
So now, what if we have MD of the company, we have HR of the company, we probably have ED, we have MD, we have HR, we have ED, and what if these three people need to print? I've actually been to a company where the MD was given a printer, so the printer is here and is connected to MD's system with a USB cable. The HR was also given a printer. The printer is here, and it was connected to HR system with a USB cord as well. ED has his own printer, and the printer was also connected to ED's PC. And so, to me, this is a mere waste of resources, right? Now, but then they have that's the only option they have because they don't have a functional network. And the challenge is if any other staff in this company needs access to the printer, they can't because the printer is not connecting to their own system physically. And so what they could do is use a USB device to copy the document they want to print and take that USB device all over to one of these three systems so that they could print from it. Now, it's not efficient. So what I did was, okay, we don't need this, we don't need this, we don't need this, right? For this company, just a printer is enough. What is actually a solution to this is to not just get a wireless printer or wired printer, but to make sure that the printer we are getting is a network printer, right? Oh, okay. So the printer should be a network printer. A network printer could now be wired, which means we'll need a cable to connect it to a switch. It will no longer connect to anybody's PC. It will connect to a central network switch. It could also be a wired wireless. So it could be wireless, it could be wired. But the point is that the printer we are getting should be a network printer, meaning a printer that can connect to the network and shared. A network printer can be shared. And when we share the printer, it means that anybody on that network can locate the printer, regardless of which floor they are. They can locate and print from that print device. So that is the perfect solution for this. But then the challenge is that you cannot share a printer. You can't share a printer if you don't have a network. You can share a printer if the printer is not a network printer. So you see, we can actually share hardware where we centralize printing in the entire organization, having a centralized printer where any of the staff, as long as they are found on the network, on the company's corporate network, should be able to use the printer regardless whether the printer is having a physical connection to their PC or not. That is no longer required. So the printer is connected to the network, the printer is shared, and anyone that have access to that network should be able to make use of it. And that actually is still part of resource sharing, but then hardware. So I use an antivirus as an example of resource sharing, but it falls under software. And here I'm using printer as still an example of resource sharing, and that falls under hardware. So in a nutshell, both antivirus and printer are examples of resources that could be used by any of our employees to carry out their official duty. We know the antivirus helps to protect the employee system from malicious attack, while the printer allows them to have access to hard copies of their documents. In either case, both of those resources, both of those examples, antivirus and printer, they fall under resources. I hope you understand basically what a computer network is and why companies cannot do without a computer network. Because if you are not on the network, then you are no longer in this world. You'll be isolated. You won't get to read the news. You won't get to see what is happening or hear anything. But with a network, they say the world is a global village. So as a matter of fact, if there is no network, then you can't be hearing me from Canada. You can't get to hear me at all. So
yeah, that's the beauty of the network, internet, eh? Like the blessing. Yeah.
Yeah. So I hope the networking is well understood.
I have one more question about the hardware, like connecting with the printer.
All right.
If it's a company, Can people still put a virus through the printer or no?
Can people install what?
No, like for example, you were explaining to me how like printer when you're connecting for a company that it's a big, say 40 or 400 people, and they all connected their computers connected to that one network printer.
Okay.
But can people put that virus through can they get it through their through the printer and get it to their system or no?
Okay. So I think what you are.
Do you understand correctly what I'm trying to say? Yeah.
Yeah, I get your question. What you're saying is it possible that a virus is spread through a printer? Is that the question?
Yeah, and getting to the people their PC or laptop or whatever they're using.
It's very possible, but again, as cybersecurity professionals, when we look at the defensive part of cybersec, when we eventually get into cybersec, we'll see what measures we need to put in place to ensure that something like that doesn't happen. But if no measures is taken, it's actually possible.
Got it. Okay, thank you.
All right. So now what we have discussed so far is what exactly is networking, and that's what we have discussed. We've also looked at the benefits of having a computer network. It helps companies to share information. It also helps them to share resources. All right. And we looked at examples of what a resource is in terms of software as well as in terms of hardware. Now I want to look at the different types of network. Basically, before I look at the types of network, I just have a diagram here just to buttress what we mean by a network. And the different kinds of devices that can be found on a computer network. So if you look at this diagram, we have a couple of devices here. The devices you should be familiar with are these ones: laptops, smartphones, your desktop, the PCs. So you're familiar with these devices, and this is a printer here. So see what I just explained. You have your scanner as well. I just explained that in some companies, they have a printer attached to a system. And in this design, is only the system that is having a direct connection to the printer that can print. So which means this system here doesn't have a direct connection to the printer, so it won't be able to print. So the person that owns this system will have to copy his or her document into a flash and take that flash all over to this system here before he can print. But we are looking at a different design where we get a network printer, and instead of this printer connecting to this PC, the printer could connect to a central device called a switch. So you could see this is a switch, and this is also a switch. So in a network, all the PCs, if the network is a wired network, all the PCs are expected to use a cable to connect to a central device called a switch. And that is what we are having here. So every single device must connect to a switch, including server. So you see a server here. And when you have these switches, mostly more popular switches, we have 24 ports. A port is an interface on the switch where you can connect a device to, right? So if a switch has a 24 port, it means that that particular switch can take 24 PCs or 24 devices, including printers. So in a situation where the number of our staff is more than 24, you know what we should do? We need to buy another switch. And that's why you are seeing two switches here. So we are assuming that we have like maybe 35 employees. If you're having a 24 port switch, there's no way to accommodate 35 devices. So in this case, you need two switches. And if you want a PC in switch 1 to talk to a PC in switch 2, the two switches, both switch 1 and switch 2, will have to connect to each other. And that's why we are seeing these guys connect to each other so that systems here can interact with systems here. But then when we want the systems on the two switches to gain access to the internet, to be able to send mail, to be able to stream, go to YouTube, etc., switches cannot take our employees to the internet. In that case, we need to buy another device called a router. So we'll soon get into networking devices. I'll be able to break down the role of each of these devices and when we need a particular device. But in this diagram here, just note for internal communication, for people to access each other within the network and access a printer, you need switches. But for people to get to the internet, you need a device called a router. And then for some people to connect wirelessly, you need a Wi-Fi router that has an antenna, a little antenna that helps you to broadcast signals so that your laptops and your mobile phones can connect wirelessly. And the situation where you want people on wireless to access people on wired, then your wireless device will also have to connect to the switch. Okay, so we take it a step at a time, but this is like a high-level network diagram that captures all the things we've been saying all this while. So now let's look at the different types of network that we can build.
Before we move back, I have one question about that.
Okay, all right. About the diagram. So go ahead with the question.
Yeah, the diagram. Yeah. So the switch that you have in the middle, I thought like that's a booster. So that's not a booster, right? The two switches that you have in the middle.
Okay.
It's not a booster to boost the internet. It's not, right? Like it's completely something different that company has. For example, in my house, I have a router And then
Okay.
I have the one you have a Wi-Fi router. They call it here as a booster.
Yeah.
So it boosts like internet. But the switch, I thought at first that's the booster, but it's not, right? It's a completely different for the
No,
companies.
no, I get what you're saying. A booster is, we call it a signal extender. In wireless,
Oh, okay.
yeah, in wireless networking, the router that they installed in your home, probably the signal is not getting to your living room, or is not getting to your kitchen, or is not, maybe you live upstairs and when you are downstairs you don't get signals. In that case, you can get a booster or signal extender just to ensure that signal goes beyond the coverage limitations that the router has. So
Okay.
that's what that guy does. So it helps your Wi-Fi signal to go further than the router can carry it. But in a wired network, where we are not doing wireless, like in banks, you do wired. Everybody will have to connect to the switch, because wired network is faster than wireless. And wired network is also much more secure than wireless. And so when we are using wire, meaning there will be cables that we'll be using. As a matter of fact, I want to show you a diagram that will help you to understand what I'm talking about. So you see these blue cables, you see these blue things coming out? All
Yes.
these things you see are switches. There are some small holes that the cables are to connect to. So these cables are coming out and they are going to different departments. And in those departments, the staffs are seated on their desk. And one of these cables will go to this staff's PC, and another cable will go to the other staff's PC, and all that.
Got it. Okay, now I understand. The switch and the booster is completely different. I'm glad that I asked you and you clarified for me. Thank you.
Okay. So the internet is located here. So there is
Yes.
internet already here. And so we need to ensure that we distribute the internet to all the systems. And that's what the switch is doing. So it helps us to distribute signals to all the systems so that those systems have access to the network.
Yeah.
I hope you got that.
Yeah, it's very clear. Yeah.
And at this point, we want to look at the different networks that we can set up depending on the requirements. So the network, we set up a network if there is a need to have that particular network. So network types. So we have a LAN, and basically a LAN means a local area network. That's what a LAN is, local area network. And so I just showed you a switch, and on that switch that I showed you, we saw that there were cables. Those cables are called network cables. And those cables are going to the different locations where we have our staffs seated. And each of the cables will have to connect to each person's PC, right? So when you have a network like that, where every system on the network is connected to that device called a switch with a cable, that type of network is called LAN. Simply put, local area network. That's what a LAN means, local area network. And basically it's a wired network, and every system on that network must be connected to a device called a switch using a cable. I hope that is clear.
Yes, very clear.
So a local area network is a wired network. So it's not a Wi-Fi, it's wired. So there must be wire or cables connecting all systems to a central device called a switch. Now, when there is a need, maybe there are some places where cables cannot pass through, and we could use Wi-Fi as an alternative in those locations that we cannot run cables. Otherwise, every company will prefer their network to be wired. Of course, the reason being that wired network is much more secure, and wired network is much more faster than Wi-Fi. And these two reasons will make companies to prefer LAN over Wi-Fi. Wi-Fi is actually what we call WLAN. The W meaning wireless LAN. Okay, so the W here is what separates the WLAN from LAN. The LAN, local area network, is a wired connection. There will be cables connecting everybody to switch. But WLAN, wireless local area network, wireless, meaning there will be no cables. In that case, we'll be needing a wireless router. They will have antenna. Some of them will have two antenna, two short poles, or some have just one, while some don't even have. They have it built into the device, right? So if you have a wireless router, all your smartphones, your laptops, everything you have at home, your printer, everything will connect wirelessly, no wire, to the wireless router. And the wireless router is the source of internet. And so it helps you to push internet wirelessly to all these other devices. And that is a wireless network. But note that this wireless network is not as secured as LAN, and is not as fast as LAN. So if you are designing a network solution for a company, you make sure that the backbone of their network is built on a LAN. Why? For security and for speed. And so where areas, some corners of the office that is difficult to pass cable to, we could now use wireless or WLAN to connect them to the network. So apart from LAN and WLAN, we have VLAN here, and VLAN stands for Virtual Local Area Network, or virtual LAN. So what exactly is a VLAN? It's a virtual network. Simply put, if I want to put security within my LAN, what I can use to do that is called VLAN. So in my LAN, I'll have all the systems on the network connected to a switch. Once again, if I bring up that image, so if this is my switch and all the devices in my network have their own cables coming to the switch will be hidden somewhere in the IT room. So even the staffs are not allowed to get into this IT room except you're an IT staff. And so all the cables coming out from here are going to our employees' PCs. Now, some of these employees connected to these switches here may belong to different departments. Okay, so you might have some belonging to sales department, you might have some belonging to marketing, you might have some belonging to HR, admin, or finance, different departments. So as long as all of them are still on the same LAN, they should be able to talk to each other. That's why it's called a LAN. But what if there is a need where the management doesn't want sales to access finance, or they don't want sales to access HR? In that case, they are looking at privacy. They want the document belonging to HR to be accessed by only the members of HR, and the document belonging to finance department to be accessed only by the members of finance. Meanwhile, remember that all of these departments are still connected to the same LAN, and there is a security need now for us to segment them and make some departments not to be able to access another department. In that case, what we can use to achieve that is to configure a virtual local area network on top of the LAN. So the virtual LAN helps us to bring some isolation, confidentiality, and privacy on top of a local area network, where we're able to restrict members of a particular department from accessing another department, even though all of them are still on the same LAN or on the same switch, but they could be segmented and prevented from accessing each other. So if you want, depending on the use case, if you want people on the LAN to only communicate amongst themselves that are in the same department, and those that are on different departments should be prevented from talking to other departments, then we can set up a virtual LAN on top of the LAN. Now, we have one here, which is wide area network. Wide area network. So what is a wide area network? Is a collection of two or more local area network. So you might have a local area network in your Toronto office, and you have another local area network, maybe in Quebec. And there is a need for the local area network in Quebec to communicate with another local area network in Toronto. Then as a network professional, you should be able to set up and configure a wide area network to allow the network in this location to access the network in this location. And so the two locations will be able to access each other as if they are in the same building, whereas physically they might be maybe 1,000 kilometers apart from each other. So when we want devices in different office locations to be interconnected so that they can share information and resources as if they are in the same building location, we need to set up a type of network called wide area network. I hope you get the explanation of these network types.
Yeah, very well. You explained really, really well. Thank you.
All right. So, and then the last type of network here is virtual private network. So virtual private network, also known as VPN. I want to explain some things here. When we talk about VPN in most of my classes, my students will mistake it because there are other VPN softwares. There are VPNs that are just software, right? And these VPNs can help us to hide our identity when we're on the internet. So examples of this VPN are NordVPN. We also have ExpressVPN. This type of VPN allows us to change our location on the internet or change our identity. So you might be connecting to the internet from Canada, but you want it to appear as if you're in the US, you could use a VPN. But that is not the type of VPN we are talking about here. This VPN we are talking about here is a security technology. So when we are connecting our office locations together, it's called wide area network. But this wide area network doesn't have any protection, which means that the company data we are sending from office A to office B could be hacked. And so how do we protect company data as we are sending from one local area network in Toronto to another local area network in Quebec? We set up a VPN on top of the WAN, right? So first off, we set up a wide area network. And then secondly, we use a virtual private network to protect the information passing through the wide area network. Just as virtual LAN is used to secure the LAN, a VPN can be used to protect the WAN, so that people will not have access or unauthorized access to data or company data that we might be sending from office A to office B. So if you want to protect your company's information over the internet, you need to set up a VPN connection. And this VPN, we'll look at it in detail as we move ahead, though there are two types. We have site-to-site VPN, And this is the one we set up when we are connecting offices together. You're connecting an office in Toronto to an office in Quebec. You need to set up a site-to-site VPN to protect your data, your company data, passing from Quebec to Toronto. But there is also another type of VPN called remote access VPN. So this remote access is the one we set up when we want some of our staff to be working from home. Of course, this is 2023 and remote work has become a norm. And so most people no longer have to drive down to the office on a daily basis. They could just be given an official laptop, an internet connection, and they work from the comfort zone of their homes. So how do we protect the information that is leaving your laptop and going to your company's corporate data? Is by using a remote access VPN. And so people could be able to work from their homes. But when we are connecting offices together, the type of VPN we should be setting up is site-to-site VPN. Or when people want to work from home, the type of VPN we should be setting up is called remote access VPN. And those are the different types of network. The use case will determine which type of this network should be setting up. So it all depends on the use case. The need that our company has that we are trying to solve will decide what type of network we set up for them. So those are the types of network. Once again, if you have any question, please go ahead and ask before I show you examples of these network types using diagram.
Yeah, it's really good.
All right.
I'm good.
Okay. So the local area network is something like this. So we have a switch at the center, and every system, whether it's a server, whether it's a laptop, whether it's a desktop, they must be connected with cables. And I've showed you how the connections are done when I showed you that picture that has cables coming out from switch to different systems on the network. So you can have different manufacturers of these switches. There are switches made by Cisco. There are switches made by Juniper. HP also makes switches, right? And these switches will be the central connection hub of your network. And we need to use a network cable called category cables. Those blue cables I showed you earlier are called category cables. So each cable will connect each PC to the switch. And in your network, you could also have servers. Servers could be a central place where all your employee systems are saving their data. Okay. So all the systems here, when they finish their day-to-day activities, they can send their jobs to the server so that if anything happens to this system, or maybe this system is stolen, all the info that are lost on that system could be pulled back from the server by the time the company gives the employee another system. So, and when we talk about servers, we have different vendors or different manufacturers of servers. Once again, HP too makes servers, and HP servers are called ProLiant. Dell also makes servers, and Dell servers are called PowerEdge. And then we have International Business Machine, IBM. They have their Z-series servers as well. So this is a typical LAN setup. So the point I want to pull out here is that we need to have a switch. We need to have category cables, and each cable will connect each system to the switch. Another type of network we discussed was wireless network, which is called WLAN or wireless local area network. So you could see a router here. This particular one is having 3 antennas. So these things you see are antennas. And that's what they'll be using to send out signals so that your mobile phones, your laptops, your tablets, your wireless printer, all of them can connect to the wireless router wirelessly. That's why it's wireless. So there won't be any wire. There won't be anything connecting this guy physically to the device. They will connect wirelessly. So when we're setting up a LAN, we get a switch. When we're setting up a wireless, we get either a WAP, a wireless access point, or a wireless router. So any of these two can be used to set up a wireless. Well, what is the difference between using a wireless access point to set up a wireless? If we use a wireless access point to set up a wireless, we will not be able to do filtering. And what do we mean by filtering? You might want to block some people from going to Facebook or going to maybe YouTube. If you are using a wireless access point, you can't filter websites. But if you're using a wireless router, filtering is supported. So you could go to your Wi-Fi router and block out some websites that you don't want some of your home users to connect to. And so regardless, both of them can be used to set up a Wi-Fi, either a wireless access point or a wireless router. Or when we are setting up a LAN, which is a wired network, we'll be needing a device called a switch. Okay, so, and then here we have an example of a VLAN. So you could see here we have how many PCs? We have 4 PCs. 1, 2, 3, and 4. Now, let's say that these 2 PC are on sales. So you can see sales PC 1 and sales PC 2. While these 2 PCs are engineering, so we have engineering PC 1 and engineering PC 2. When a VLAN has not been configured, and what we have is LAN, then all these 4 PCs should be able to access each other and share resources. But the moment you place a virtual LAN on top of the LAN, then it's as if we have divided this network into 2. And engineering can talk to engineering, sales can talk to sales, but it's no longer allowed for sales to talk to engineering. And that's the power of VLAN. So devices or PCs from different departments are no longer allowed to access each other. That is what VLAN is all about. And then the other type of network we talked about was virtual private network. We said here is the head office, and here is a regional branch offices, and people here will be allowed to access resources in the head office over the public internet. We know that internet is risky, so that's why we are taking the security into our own hands by setting up a virtual private network to encrypt all the data that will be leaving our regional offices to the head office. That same VPN can also allow some people to work from home, that is remote users. So we'll have somebody, this can be in Canada, this can be in Germany, and the head office is maybe in Poland, and all of you could be working, accessing the servers, applications running in Poland office to do your job while you are in different parts of the world. That is possible because of remote access VPN. Okay, so those are the small diagrams explaining those network types that we have discussed. All right, so now let's quickly look at network devices. Just a recap, here we are discussing basic networking concepts. We have defined what networking is all about. We've looked at the benefits in terms of sharing resources and sharing information. We just looked at types of network where we discussed LAN, VLAN, WAN, etc. And now the last thing we'll be talking about today is network devices. So as I said before, if you are setting up a LAN, and of course we know that we can protect a LAN by setting up VLAN on top of the LAN to prevent people from different departments from talking to each other. So a device we need for setting that up is called a switch. But if you're setting up a Wi-Fi, which is a wireless local area network, you can use a device called a WAP, which is a wireless access point, or wireless router. I've explained the difference between the two. A wireless router can help us to do URL filtering some sites out, while a wireless access point cannot do that. Now we have wide area network, which is a way of connecting one LAN in one location to another LAN in another office location. And we can use a router. This is a wired router, not wireless. So the likes of Cisco are the ones that produce this kind of router. So whenever we are talking about connecting offices together, the best router to do that is wired, not wireless. And Cisco is one of the leading vendors that make wired routers. Connect the network in these two different locations together in a secure way. We'll have to set up a VPN. So devices we can use for VPN setup, it could be a router. It could also be a firewall. So a firewall is a security appliance. So in the cybersecurity class, you see a firewall and see how to log into it and configure it. It's an appliance that in it we could block some websites, we could stop some malware from coming into our company IT infrastructure. We could prevent cyber attacks from breaking into our systems and all that. So these are the kind of things you could do inside a firewall. Things like intrusion prevention system, things like intrusion detection. These are the capabilities of a firewall. So a firewall can do VPN, a router as well, wired router can also do a VPN. So all these network types, LAN, VLAN, WLAN, WAN, VPN, at the right-hand side here, we see the kind of devices that we need to purchase depending on the type of network we are setting up. And here we have optimization. And optimization here, I place a load balancer. So a load balancer is used to optimize network performance. What I can do to quickly explain a load balancer is, let's assume that you have a server. So you have a server here.
Yeah.
And you have another server here. Now, why should you actually have two servers? So that you have a backup of this server, just in case this one suffers hardware failure. So your company could go ahead and host their websites on this server so that our customers could browse to our website and probably purchase some items on the website. And we want this website to always be available. And so we are using another server where a copy of the website will also appear on the second server. We want the system to be highly available in such a way that if this server should go down, the website should still be accessible because there's a backup server that will be covering up for the one that went down. Now, the whole idea here is that if we're not using a load balancer, putting a load balancer in front of these two servers, then it will not be efficient. So what does a load balancer do? So if we have like 500 users trying to access our website, the 500 users traffic hits the load balancer, and the load balancer will share the load equally, where it sends 250 to the server and 250 to the other server. But if a load balancer is not configured, it means that the whole of 500 traffics could be hitting just one server, while the other server is doing nothing. So the other server can only come into the picture if this primary server goes down. So if we want this server to be equally working and equally sharing the load, then we'll have to get an appliance called a load balancer in order to optimize the availability of our application. So that's what a network load balancer does. We have a network load balancer, NLB. We also have application load balancer, ALB. So now we have storage. Once again, we need to store our employees' data to a central location, and that central location could be a server. It could also be a NAS. NAS is network attached storage. So it's a storage device that is connected to the network so that all the devices we have, all the data or the documents that we have in our mobile devices, in our laptops, in our PCs could be centrally stored in a centrally configured network device, either a network server or network attached storage. So for storage, we want a situation whereby you'll be able to recover from disaster. Now, what is disaster? A system here could crash where we cannot recover anything, any document on that system because it has crashed. So we lost all the data. But if we have a storage device, we should be able to recover all the lost data back when we eventually buy another system for that particular employee. Or it could also be that this system is stolen, and so we no longer have access to any data in it. And so we could get another system and restore all the data back from a central storage device on the network. So these are the different activities or different technologies that we may need to set up within the network environment. And the right-hand side here are the kind of devices we need to purchase depending on the use case or the need that we are looking at providing solution for on the network. So that's what we mean by network devices. And as we go further in this course, we are going to eventually be logging in and setting up some of these devices. And obviously, you should be able to also set up the router that is installed in your home. And you should be able to look at if it's a wireless router or a wireless access point. If it's an access point, it shouldn't be able to do web filtering. But if it's a wireless router, you should be able to block some website for some home users at a particular time of day. If one has kids, you could restrict them access to the internet from maybe 6 p.m. down. Different scenario, different use cases. But the point is, at the end of this training, you should be a network engineer that not only understanding what all this concept is all about, but also be able to know how to implement them in a real world environment. So that's the introduction of this course today, and this way I will be dropping the curtain.
So I have one question about before we move on this about the storage. So the storage, you say if you have the storage,
yep.
Even if the company system crash or if it's stolen,
yep.
you still can track that, right?
Yeah.
But you have to have a storage that
yes.
NAS. Okay. But if you don't set that up, you will lose everything.
You lose everything.
It's like us saving. I'm just giving you a metaphor. Like USB, right? Like when we don't want to save important stuff on the computer, or we're afraid if the computer crash that we're gonna lose, we use sometimes USB, right? Like to save the it's similar to that, but in the iCloud.
Yeah. And then you know that there are some data you cannot afford to lose. So there are data that are even worth more than any money in the world. So if you lose that data, the company is as good as folding up. So it's part of disaster recovery measures we need to take.